Welcome everyone to another Innovation Coffee. Today it's going to be a special one. It's called Innovation Coffee Becoming an Avatar. I'm really excited about this show. It's going to be an interesting one. We're going to see some really cool stuff. As you can see today, I'm alone. So Robert is off on holiday. So I'm happy for him that he's got some time off, and I'm excited to be here with you guys. So thank you all for joining. And as usual, I wanted to just give a bit of a recap about last week's episode. So last week we actually had a really good show on OctoML. We talked about compilers in the ML space and what it means to utilize compilers in the context of ML. So it was a really fun show. So as usual, you can go check out that show on our YouTube channel. And now, without waiting any longer, I'm really excited to bring on the show the two guests from Roboy. So here we go, Rafael and Alona. Welcome.
Hey there. Hi, Alessandro.
Hi.
Hey, you too.
Hello. So we got Rafael, the founder of Roboy, and Alona, the head of software development at Roboy. So welcome both on the show. It's really great to have you here.
Thank you.
Thank you. Really love to be here.
Awesome. And who do we have there? We introduced two people, but I see almost a third person there.
Exactly, yes. He's a great member of our society almost. This is Roboy 3.0, our latest creation, so to say.
Awesome. Cool. And I believe we're going to see some a little demo afterwards, right?
Yep. You will see it in action, so stay tuned.
Cool. But before diving into Roboy, the special guest on the show, I really wanted to kind of, as usual, go back and first talk about your journey, your story, what brought you to develop a robot. And I think it's also going to be interesting to discuss what this actually is, because it looks like a robot, but it's more than a robot, right? So we'll talk about that in a minute. But yeah, before that, Rafael, do you want to start with, give a bit of introduction on yourself and your journey to Roboy?
Yeah, sure. So I'm Swiss. I'm living in Germany now. I studied computational science at ETH Zurich, and sort of when completing my master, I didn't really know what to do. The Roboy project was actually started by Rolf Pfeiffer. He's a quite famous embodiment professor. So he's like in robotics, there's this direction called embodiment, where basically the idea is that you can only solve intelligence when you actually have a body that interacts with the world, because that's what sort of is the thing that creates intelligence. And the first Roboy Junior was actually sort of his legacy. It was the big ending of this. And I was a part of the project, loosely connected to it, helping with the design, working with the designer from Disney Research that sort of did the first sketch how this robot might look like, but then went actually for a PhD to Berlin. But sort of quickly realized that computer graphics is not exactly what I want to be doing forever. And then Roboy was sort of done 9 months later. And I came back to Switzerland, saw Roboy, and was like, this is such a great robot. Such a unique idea, having a robot that is sort of inspired by the human body. So it's a musculoskeletal robot. That means it has muscles and tendons. And that's different to almost all other robots that you can find out there. It really tries to sort of imitate the functionality of the human body in order to replicate the mechanic behavior of that our body has. And I was like, well, what do you plan on doing with this robot? And they were like, well, we don't know, actually. We built it as the big finale of Rolf Pfeiffer's laboratory at this 25th anniversary. But there's no plan. And I was like, well, that's good. I would take it. I'll adopt it. And that's how I brought it to Munich. And then I started building the robotics team. 2 years later, Alona became one of the first actually that joined this humanoid robotics teams. And from there on, it took us a few years to actually develop the second Roboy. And then now, sort of after 7 years, we have Roboy 3.0.
Awesome. Really cool story. I'm going to ask you a couple of like really kind of simple questions, but I think interesting questions. So first of all, what was your first robot that you ever kind of got, that you got exposed to, I guess, as a kid? What's the first robot memory of a robot?
That's a really good question. I have no idea. Like it doesn't come. Maybe a Roboy. No, but so I was taking care of Eche for a while. Like this is sort of the father in spirit of Roboy. It's a robot. It's one of the first musculoskeletal robot, and that was how I sort of came into this whole robotics area. Playing with it's a very unique robot. It's currently also being exhibited. It's now in the museums and travels the world as a museum exhibit.
And the second question, then we'll go to Alona and we'll have her introduce herself. But the second question is, what did you think of being when you were younger? Right? Did you think of becoming a roboticist? When did that come up? Rafael.
Sorry, I said it was for Alona. It's a good question. Actually, it sort of came during my studies. I always wanted to do something with tech. I always wanted to do something that has impact, and that sort of unites as much of the world's knowledge as possible. And robotics is really excellent for this, because trying to build a human body requires knowledge from engineering sciences, informatics, AI, but down to biology, medicine, and so on. So it's really a huge, very broad field, and it's actually the perfect field to play around if you want to know everything.
I like that. It sounds like an interesting field.
Oh, it definitely is. It's hard too.
Yeah, I can imagine. Right. So Alona, let's dive into your story then. Do you mind telling us a bit about yourself and how you got started?
Sure. So I'm originally from Ukraine, now based in Munich, where our lab is also, where I'm currently sitting. And I studied applied mathematics back in Ukraine, in Kiev, my bachelor's, and then I was hunting for master's degrees outside of Ukraine to expand my views and so on. So I ended up in Munich studying robotics, cognition, intelligence at the Technical University of Munich. And then in the end of my first year of the studies in 2015, I saw a poster with a Robot Junior on it, and I was fascinated. I was very curious, what is this robot? And I went to the first student team meeting that Rafael organized, and I fell in love with the robot and the whole vibe that was created then. And now, 5 years later, I'm still here. So this is a short story. Oh, you're muted.
Oh, yes. That's really, really nice story. I'll ask you the same questions then. What was your first robot that you kind of came across when you were younger? Do you remember?
Yeah, I don't remember any other robots in my life other than Roboy. They just all disappear.
That's the only thing I stuck. What about guys? What about movies? Like, did you come across any like kind of robotic movie when you were younger?
I mean, of course, the Star Wars movies were sort of the first movies I can remember where robots were a thing. But curiously, I never connected this until just now to thinking about robots.
Yeah.
I mean, for me, maybe this positive view of robotics was the WALL-E that shaped it. Maybe, I don't know. But the movies that I remember about robots, it's all bad and they're gonna capture the world. And this is something very different from what I'm building now. Right.
And I think that's a good segue into Roboy, right? I think that's what fascinates me about your vision and what you're building here is that you've got a very positive vision of the future of robotics, right? And I think and also you're building something that's actually a platform for others to build upon, right? And I think that's super cool. So that kind of empowerment piece, right? I think it's super interesting. So I really like to understand more about Roboy before we get it moving. But yeah, so whoever, Rafael, do you want to take that? Can you tell us more about what Roboy actually is? Tell us, what is the vision, I guess, and then we can talk about actually what it is, right? Because I think that's the second question.
Yeah, so the vision is actually quite simple. So in 30 years, the answer that you asked in the beginning, who is sitting beside Alona, this would be me. So that's the goal. I really want to become a robot so I can live indefinitely. I want to keep on living for the next hundreds of years. There's just too much good science fiction out there that I kind of want to experience. Yeah, it's crazy. Like I'm currently reading a lot also science fiction. It's like you keep reading. The Culture series, maybe you know it, and it's like there's so many things that are like possible in this universe, and I just want to be there. And that's what the vision behind Roboy is. And then of course the problem is it's not a very fundable vision. You can't go to anyone and be like, yeah, okay, I need between 10 and 30 billions. I'm not entirely sure how I'm going to do it. It's going to take 30 years time, might be a total flop. Can you give me the money? It's not, kind of doesn't work. Like you're not going to find many people that were like, yeah, here, take it. So what we're doing is like going step by step. And what we have been doing the last 7 years is sort of trying to build a better and better musculoskeletal humanoid robots. And now that we have a decent robot, Robot 3.0 is like from a robotics perspective, and we're going to be talking, as you said, more about how it actually works and the whole hardware software stack of it with more. But now it's really a decent robot. And so the next step is becoming that robot. So we're trying now to connect humans to robots, and it's called Telepresence. So you are actually experiencing what the robot experiences. Robot imitates your motion, so it's like a shadowing of your motion. So for you, it's as if you're going someplace else. And sort of that's a logical step. And then of course, finding applications for this, but this is much more commercially viable than, hey, I have this big vision, give me billions to do it.
And I mean, maybe I can add, once you have telepresence, it becomes very relevant for many industries and society as well. So you can have remote healthcare with actually physical agency, or you can have remote maintenance of oil rigs somewhere in Siberia and so on, right? So the application range of telepresence is really wide.
And I think that's super interesting for two different reasons, to me at least. Is one is what you said about living forever, right? I think that's like probably one of the boldest statements I've ever heard from someone building a company. Like, usually you ask why are you building this, and people come back and say, because I think I want to do X, Y, and Z. But this is like, because I want to live forever. I think that's, if there was maybe, it's like one of the superpowers, right? It's like, I want to fly. I want to, it's another superpower to me. And it's super cool that, I think the journey of what does it take to live forever, and, thinking about building a robot that can actually impersonify a human being, right? I think that's super, it's a step forward, right? And as you said, like, this is just the first step, right? But the other interesting aspect of this, and we've discussed this previously together, is the fact that, with this world becoming more and more connected, actually there's an opportunity for less traveling, right? Like sometimes, you don't need to be somewhere physically if you could interact with the space around you in another place, right? So it's super interesting to have the opportunity to have a robot kind of, take your place in, at a conference or an event, or, on a factory floor, or, in a nuclear reactor, or wherever, right? I think it's
definitely,
and opening up that opportunity space is super interesting. I've got a couple of questions from the audience that I'll ask you before we dive into more details. So first of all, I guess iShot JR is asking, he saw the robot and he's saying, what is this? But we'll answer that in a short while. But actually, the more specific question is, from David, we've got a question that says, what's the hardware software stack look like? So we'll cover that in a minute. So I think we'll take that in a second. But the other one that we're getting from iShotJR is, why not skip the physical and go all software? That's what he's asking.
I think it's a good question, obviously, because in software you can live in whatever world you want to be living. And at the point where we can actually go all software, we can also create a stimulation for our brain that sort of is perfect, because these are all lower technologies than what we need to achieve. But I mean, without going into the simulation argument, this is reality as far as we know. So I would always want to be able to interact with it and see what's actually possible. I think it's kind of cheating living in a fully virtual game world where I can be whatever I want to be. I think what's really cool about reality is that it's hard and that you need to solve actual problem, and that it's a game where the rules are very unforgiving. You're not going to cheat physics, but it's a very big playing field, so you can figure it out. So I think it's a lot more interesting to try to see what's possible and within this reality than to go and build another one where you can be whatever you want to be.
Good point. That's definitely, an interesting view. And then we've got another question. Well, okay, this is more like generally, how many Roboys do you have?
Yeah, so there's Roboy Junior, the original one. Then there's a no longer complete Roboy 2.0. Which we harvested partially to build the third one, and for building things like sort of over time, parts of the electronics were taken out and so on. And then from the current one, Roboy 3.0, there's two instances. One that they're still both in the lab, but we're about to ship the second one to a partner in Hong Kong. The Chinese University of Hong Kong has acquired one. And they're doing research into the control of these robots. So it's a very long-running collaboration we're having with them almost since the beginning of our musculoskeletal journey.
I mean, on top of that, maybe a few words that we have smaller robots, so not full humanoids. We have small kits, so like 1 degree of freedom arm, or a shoulder setup, or one-dimensional legs, and so on. So we've been doing like smaller prototyping projects to understand what works, what not.
Cool. Thank you for that. And we've got another one, but I think we're going to get into that in a second. So I'll leave that for now. So I think, you mentioned one thing that I think, I caught on earlier, that's a concept I've never heard of before, actually, in robotics, and embodiment. So I wanted to ask you a bit more about that. Like, what is, I think you described it quickly earlier, but, can you spend a few more words on that? I think that's a super interesting concept.
Yeah, I think if you're looking around you or around our lives, so the only one having a robot right now is Alona and no one else. And a big question is, why is that? And then one of the reasons is because it's very hard for these robots to actually interact with the physical world. And so but even if you look, for example, at the cockroach, it has like very, very few neurons that go into each of its legs, but it's super agile and it survives almost everything and is extremely capable of sort of surviving in this world. So clearly there's some other kind of intelligence going on that is nothing that we like, the type of intelligence that we usually attribute with like reasoning or planning or problem solving. But there's also this kind of embodied intelligence that allows you to interact with the environment. And embodiment is exactly this. It's basically the idea that if you want to go to self-aware systems, we're going to create something that is able to interact with the environment in an intelligent way. It requires a body, because you need this body to be able to create the data stream that you then analyze to actually interact with the world. And the idea is that that's something you will not get to the proper intelligent system that sort of covers all aspects of intelligence unless you actually give it a body and let it sort of explore the world and sort of create its active sensing to be able to reason on top of that.
Very interesting. And why would you say you need a humanoid robot? Like what is the benefit of having a humanoid over, some other type of robot?
I mean, obviously we are, as humanity, we're building mostly not humanoid robots. We're building Roombas and industrial robots and so on. So clearly, if it comes from a purely functional perspective, if you have a dedicated singular function, other types of robots are better suited. However, we have built our world and environment for our bodies. So that the height of a table, the shape of a doorknob, everything we interact with in our daily life, it's basically made for human bodies. And if you want to have a general purpose robot that can do whatever a human can do and interact in this very chaotic, from a robotics perspective, world, you have an advantage if you make it the same shape, more or less every morphology as the human. So that's, I think, it's one important argument why we want to have humanoid robots. And the second one is, if you want to tell a robot what you want from it, like if you want to interact with a robot, and if it's a humanoid and we're getting to the point where we can actually understand well enough what the user wants, the humanoid has an advantage in we're kind of used already as humans how to interact with other humans. So if you have a robot that has two industrial arms instead of human arms, and for him to grasp my phone and pass it to me, he could pass it to me like this. Like, this rotation, there's no mechanical or energetic disadvantage in any way for that robot to give it to me in a rotation fashion. It's just nothing a human would ever do. And therefore, the interaction between the human and that receives this phone is worse, as when it's a humanoid robot that sort of does the same kind of motion that the human is doing, because you're just expecting this as a human. So for human-robot collaboration, this is actually a big asset. Being able to naturally generate the kind of trajectories and interaction that you're kind of already expecting because you're just projecting everything you know from a human onto the robot. I think that's sort of the two core reasons. I mean, there's a lot of disadvantages, of course. I mean, these are very complex systems with lots of moving parts, very hard to build, thus still very expensive. Does not really commercially viable. I mean, that's one of the main reasons we're not really seeing large amounts of humanoid robots out there, because there's not we kind of need a way of jumping from, okay, we kind of want to have it, but it's costing way more than we ever want to spend on it, to the point where we're producing so many of them that we can produce them cheap enough that we want to give it to everyone. And that's sort of this chasm. This is where we kind of need to jump. I need a way of doing this.
Yeah, and I guess the other thing that I've heard before is that as humans we tend to interact. We tend to like to interact with things that are more similar to us, right? So especially when it comes to like normal interactions. So I guess having a nice robot that looks like a human being somehow probably puts us in a better position to be able to interact with it. If the objective is to have the Roboy interact in the world as a human, then it's probably another reason to have it look like a human.
Yeah, and what is super important though, and this is like one of the reasons I think that social humanoids are not very well received so far. I mean, there's a bunch of them out there, and generally, if you've ever played with one, it's like it stops being interesting after a few seconds. It's like you try with it, and it kind of immediately violates your expectations. So you expect you can talk to it, you expect that it understands who you are, what you're doing, what your emotion are meaning to it, and it doesn't. And because it's sort of immediately violating this expectation, you immediately lose interest, because you don't know how to approach it anymore, because you kind of knew 2 seconds ago, and it turns out that's actually not the case. This is not how you should approach it. But then what pattern should you apply? And I think that's one of the main reasons we are that we need to, for social robotics to actually work and humanoids to work, we need to become good enough with our AI systems to understand so well what the user wants that we don't no longer violate these initial expectations of the user. And I think that's the moment where social robot's going to click. And that's actually one of the main reasons, because I think this is actually quite far away from what I've seen so far. It's pretty hard to do, and it's one of the reasons everyone builds toys and cats and animals, because there the expectations are much lower, and we're also much more happy to be okay. Yeah, that's cute. So it's one of the main reasons we do telepresence, because we can, from the start, from the very moment that telepresence work, we can actually fulfill this expectation. If you approach a teleoperated robot that's being remotely operated by a human, this robot can fulfill all your expectations, whereas an autonomous robot cannot. It will immediately break apart. And I think this is sort of the way we actually be able to get humanoid robots into the actual environments we want them and need them to understand and to learn how they can work there.
Awesome. No, thank you for that. That's super cool. And I guess that brings us to what Roboy actually is, right? So we talked about this offline earlier, and it's quite interesting, right? Because it's a robot, right? But I was thinking, is it an exoskeleton? Because effectively, you were talking about being the robot, right? So I was kind of thinking, is it a exoskeleton? And then I'm like, no, actually, no, because you can't really wear it. But then, is it a telepresence robot? I think it's probably a bit diminishing to say it's just a telepresent robot, because actually it's much more than that, right? So actually, we were chatting before. It's like, how do you define it? And I was saying maybe it's an avatar, right? Like it's or we could call it an avatar. But it's quite interesting. Like, what is have you tried to define it? What kind of terms have you used before?
Yeah, actually, we had quite a lengthy discussions about what to call it. There were ideas around correct peripheron and other words, but they're sort of new, give ways of defining a new system, because avatar kind of has this problem that we also call virtual avatars. So this whole idea that this is an actual robot, this is an actual physical system that is big and hard to do, and like it kind of it's kind of bad to subsume it under something that is comparably easy to build. Like it's super easy to build a virtual avatar, because you don't need to actually handle physics. Whereas it's super hard to build a physical avatar robot. But yeah, so if anyone has a great idea how to call these systems, we're still looking for great names. It's actually quite hard.
Awesome. Cool. I think we talked about software, right? And you mentioned about machine learning actually playing a really important role. Not so much in, I guess not so much in having the robot think and, perhaps react to things. But I think, well, in some ways it is, but I think actually you hit a point that is quite interesting. To have the robot actually interact with the human, you need to kind of predict what they're doing or understand what they're doing, right? And that's, I guess, an aspect I never thought about. I always think about, interacting with the external world, right? So like machine learning to understand and interact with the external world, where in this case, it's actually a step above that. It's actually interacting with other humans and making sure that your interaction looks human, right? Or appears to be usual and not weird, right? So that's super interesting. So Alona, maybe you can shine some light on the software side of the robot.
You mean in the way of what are we using and the whole software stack, if it go deeper in the detail?
Yeah, absolutely. Yeah, I think let's start from like the high level picture, and then we can dig in. There's probably going to be questions from the audience.
Okay, it's a very large topic to cover, of course, but maybe quick explanation on the technical specs of Roboy. Maybe people are interested. So what we have here, there is a Jetson Nano in his head, and these two cameras are connected to the Jetson Nano, and this is how we stream the data. Then the face is back projected, so there is a beamer with Android system running that is projecting the face, and he can actually show different kinds of emotions and speak and move his mouth and so on. And then we have in his whole body, we have I think 60 muscle units. So 48 larger muscle units that move the neck and then the shoulders, and then 12 smaller muscle units that control the wrists. And both of these kinds of muscles we developed in-house. Yes, then in the middle we have Matrix Creator with a microphone, and the whole motor control is running on an FPGA DE10 Nano SoC, using our custom bus implementation based on UART. What do I have to say? So this is like hardware overview.
What are those? I see some. They look like different development boards on in the chest. What are those?
On the side, yeah. This is our motor. This is the motor board. So
okay.
And each muscle consists of the Maxon DC motor, and then there is a spring that surrounds the motor and the motor board. And then there are 10. I think you don't see it, but on the neck you see the tendons. So if I'm not wrong, it's nylon or
it's called Dyneema.
Dyneema, right?
Yeah.
Right. Dyneema. So each muscle has a tendon that is connected to another link of the body. And for example, neck is a 3 degrees of freedom joint, and we have 6 muscles that control the neck. And because we have the system of antagonistic and protagonistic muscles. So you can see here, I can move him a little bit. So this is the general idea of the robot moving. I can talk more on the topic, so I think I need some anchors.
Yeah, no, that's awesome. So no, I think that's great as a background for the hardware architecture, or what is actually made of, what Roboy is made of. I think it'd be interesting to discuss, because I know that everything you build is more or less like available on GitHub, or a lot of it is. So it's all based on open source software. I'd like to understand, kind of your view on, or at least your approach, right, to building such a software stack that could be used as a platform for others to build upon, right? So what is your approach that you've been taking in the last few years?
Well, higher level, we break fast, try to build fast, break fast, and iterate as fast as possible, both in hardware and software. But high level, it's all based on ROS. Currently, we're still on the ROS 1, melodic and noetic, but there are already some parts that we migrated to ROS 2. So basically every subsystem is running some kind of ROS package, and then this is our underlying system for it.
Awesome. And where does the intelligence sit? So like the interactions. Is there any aspects that like sit? Is intelligence a bit everywhere, or is it sitting somewhere? Where's the brain of the robot?
Yeah, it's very distributed. So as I said, for the motor control, so all of the movement, lower level movement control is with the FPGA that has an ARM core. And then we're connecting to ROS to send motor commands. And then higher movement control, like joint control. We have an Intel Nuke PC that is kind of the main compute unit of the robot. It's quite compact, so it's easy to fit it somewhere in the vicinity of the robot. And then head is its own unit, and you have the beamer there and the Jetson, so you can technically detach the head and it will be still working, more or less.
Awesome, cool. Okay, so I think we've talked a bit about the software and the hardware. Should we dive into the demonstration, or at least the showcase of Roboy in action? Do you need some time to set up Alona? Or
I can try right now, and let's see how how live demos work. So if it doesn't work, I just try again.
Did you pray to the demo gods?
Yeah, exactly. Okay, so the telepresence system that we developed, we can run on the Oculus Quest. It doesn't matter which one, first or second, but it can also work on HTC Vive or anything else that you can connect to Steam VR, basically. Well, Oculus Quest is pretty cool because you can just take it and go anywhere. And now, since I'm sitting in the same room with the robot, I disabled the speech, so I'm not gonna hear myself, and you're not gonna hear me twice. And yeah, but ideally the use case that somebody is far away and, for example, in another country, and then you teleport to this room with me. So I will try to connect to the robot. Let's see if it doesn't crash. And basically it's an Android app that we have developed, and what it does, it streams the images, the stereo images from the robot to my headset, and then it also takes the orientation of the headset. And okay, so I think you are moving, yes. As you can see, I'm moving my head, and with some delay, the robot is moving his head as well. And that's the idea. So the latencies.
No, I just love the way it moves, because it does look like a normal, like a humanoid neck, right? It's quite cool actually to see.
Yeah, it's not uncanny, right? It's not creepy. How it's very natural movement. How it is doing it. And the cool thing is that this works online, right? So I don't have to be in the same network with the robot or anything, and the latency is pretty cool. It's 200 milliseconds. So I have this feeling of embodiment, right? So like I can look at my body and then I see my arms. Currently they are disabled, but you can also control the arms, like shake hands and stuff like this. Yeah, so this is kind of the mini demo that I wanted to show.
That's awesome. We had someone. So I shot JR is asking that, or he was suggesting that, Rafael, you should have talked to Alona remotely. It would have been.
I actually forgot to bring the VR headset. I would have done that. I realized too late.
But it's cool. I mean, I think what's super interesting is the fact that you're seeing, for example, you said you were moving your head, and then you said, you wanted to check whether it was moving, right? And you realized that, I think, from your VR headset, you could see the different orientation of Roboy, right? So that was, I think that's super cool. The fact that you can embody. I don't know if in this case you would say embody the robot, right? But
it was kind of a shell. It is kind of a shell, right? That I can jump in, and I think it's worth mentioning that the streaming solution, so the streaming part, we are collaborating with the partners from UK, and it's an awesome company. They are Cybercells, and they are sharing their software. So we're like the first users, so to say. So we are their testers, and yeah, it's pretty impressive, like how little the effort does it take from the user to be somewhere else, right?
That's super cool. We've got a question from the audience, from I shot JR again. He's asking, was the 200 millisecond latency local, or would it be that over long distances as well online?
Raf, you want to take it, or should I?
Yeah, so of course, longer distances, the internet latency adds to this. Right now, this is something that we're still working on, getting the latency down. So you have quite a long pathway. If you look at the overall latency, going from the camera, then taking the camera data, compress it, send it to the host, and at the host you need to decompress it, and you need to actually send it then from the host to the headset, because it comes to Wi-Fi. So you'll have also another latency there in the and then only then it's sort of being displayed. So each step adds a little bit of latency, and of course we're trying to squidge it as much as possible in each of those steps. And then sort of there's a big chunk in between, which is network latency. And that's something we were super interested in solving as well. We're working with different telco companies to bring 5G to the robot. So we basically shortened this part, and it's I would say, like, for telepresence, solving this network problem is actually one of the biggest challenges we still have, because it's not just about the latency, it's also about having a lot of bandwidth at the very low latency and a very high reliability. And that's actually sort of a nightmare for any wireless system if you think about it, because we really need sort of, and it's one of the very few systems that needs this, we really need this guarantee that you have a connection between the robot and the operator. So right now this is local, it's not a big problem, but like once these robots are sort of out in the world, and you cross a crosswalk as a robot, you kind of want to be sure that you are in this robot and in full control of that robot. So if a car comes and it doesn't see you, you can jump, because otherwise, I mean, of course, this would just kill your robot. But nonetheless, like, this is really important that you have sort of guarantees towards the connectivity, and that's why 5G is super interesting for us, because it has something that's called network slicing that gives you sort of this guarantee for certain parts of the network. So you have a guaranteed bandwidth, and you know your packages will be arriving. At least for some packages, it will be possible.
Super interesting, because yeah, again, another problem that I never thought of, right? Like, if you've got a robot that's just kind of sitting around, if it has a bit of a delay, it doesn't really matter. But if you've got it, as you said, like walking around the street, you want to make sure that, you know, it avoids cars or whatever, and you have to do it in real time, right? Like, the car will not stop and wait for you. So I think that's an interesting.
It's actually one of the #1 reasons, I think, why 5G is not half as relevant as everyone says for autonomous driving. Because, like, if you think about driving fast, you actually need to guarantee that you can always be connected in a cell, to a Wi-Fi cell. And if you're fast, that's super hard. Like, giving this guarantee that you're connected at all times is hard. For a robot, it's different, because you have like kind of walking speed, and you have a more constrained environment. It makes a lot of sense, and you really need like, there's no way of having the compute locally, because the compute is actually transmitting the video stream from the robot, or the whole state stream from the robot to the operator, and from the operator to the robot. So you need connectivity. It's non-optional, and I think that's why it makes this such an interesting use case for these new communication technologies.
I think, but also I can speak from the experience of trying to control this robot with a bad network connection. You cannot do any task. You want to move any manipulation with an object you want to perform, you need really low latency. If I see a cup or a bottle on my table and I want to grasp it and I want to hand it over, then if I have 500 milliseconds latency, I won't be able to do this, unless robot is compensating for this on its side and it's like semi-autonomous, right?
And actually, that leads well to the next question from David. He's asking, do you see any degree of autonomous capability for Roboy? And imagine, actually, this might be an aspect, right? Like having some autonomy on its own, so that, for example, it avoids a car if it's about to get hit by a car or something. I don't know. Like, what is your take on autonomy in the telepresence world?
So, I mean, for the big vision, it's of course not as relevant, because I mean, I want to become the robot, so I don't need additional systems on top of that. But if you really look at the system in detail, there will be autonomy necessary for different aspects of the system. One is, as we said, it's safety. Basically, you want to guarantee that even if the operator is disconnecting, the robot doesn't do something stupid and hurts anyone. And that's a typical task for an autonomous system. Like, a graceful shutdown is something that you want to solve autonomously. Because you just cannot guarantee the operator stays there for whatever reason. I mean, even if the operator has a heart attack, right? You don't know. So this is something you have to guarantee, and I think autonomy is very important. And the second that is a bit non-obvious is the robot will not become a perfect match of you for quite some time. So there's differences between the morphology of your body and if you're walking, and sort of one thing that our body does autonomously is of course balancing, for example. And I don't think we will see ourselves balancing the robot, but it will be an autonomous system from the robot that maintains the balance and is sort of overlaid over what the operator is asking from the robot. And that's another place where we're going to need autonomy, because the system cannot perform like a walking motion just by connecting it one-to-one to the operator. Also because like we have very different, like it have a very different mass distribution. Like balancing yourself is a lot about the morphology of your body, where your mass is in your body, and so on. And this is different for the robot, and it will never be the same, just because it's not a biological systems. We have the motors at different places, the inertias will be different. So this is definitely a system where we're going to require autonomy. And then if you look at it from a commercial perspective, of course, if you want to make these systems viable as a commercial product, and for example, we look at healthcare and we are like, okay, so this is a robot that you can have in your home once you're a bit older, and it basically takes care of your everyday tasks, and it also does some critical tasks like helping you put on compression socks. So that's probably, for example, a task that I don't see being automated in the next 10 years. It's super complex, it requires a lot of interaction, and you're actually touching the human that you work with, so it's super hard to make this safe. So that's going to take a while, and telepresence is super useful. But then most of the time, the person probably wants something like, hey, can you make me a tea? Or can you get me X? Can you get me a pillbox? Can you do like small things? And this is nothing where you would want to have an operator in the robot at all times, or help me walk to the toilet. This is something where you want autonomy, but to make this actually a commercially viable system.
Also, maybe from a different area, an example for autonomy, higher autonomy level, if I'm a very important CEO and I have one day I have a keynote in New York, and another day, or like on that same afternoon, I have a keynote in Japan, and I don't want to steer this robot to go to the office where I have my keynote. I want the robot to get on to the office, and then I'm just there. And also I don't need another person to like bring the robot there and so on. So definitely you want some kind of autonomous capabilities.
So it's interesting, actually. David is kind of digging in on this aspect of autonomy, and I think he's bringing up a good point, right? It's like, if you've got a telepresence robot that works perfectly, could you not have it driving a car, right? Like, why do you need an autonomous car in the first place if you could drive the car from a robot with a robot?
Actually, so almost. So having remote drivers is something that a lot of the autonomous car companies are currently doing as a backup, and there's also a number of startups that they're using this as their main approach. They're like, okay, we can get limited autonomy on maybe from certain highway. This is kind of solved, but then there's the complex other places we kind of need to have an end-to-end solution. So we're using remote operators for that. I mean, for a car, it's relatively simple, right? I mean, you have a screen, you have a wheel, and you have a direct connection to that. But it's actually it's quite hard to find investors for this, apparently, because if you're familiar with Starsky Robotics, they were a truck company that tried this approach, and they actually didn't make it because they kind of sort of went up with the hype of autonomous driving, but then they weren't autonomous. And then when sort of the hype cooled down a bit about autonomous driving, they were like, the investors were like, yeah, but we don't touch the space anymore. Although their system was the one that actually makes sense from a robotics perspective. This was what truly made sense and should have been the thing that gets funded. But then, like, so it's quite interesting to look at this. It was apparently it's still pretty hard.
Yeah, and I guess the next step is what David is saying. Shot JR is actually, why could you not just we talked about this last time as well. You don't actually need to drive around if you can have your robot move and go somewhere, right? So effectively, you could have the robot, fly or drive or whatever. Like it could run, very fast and get somewhere fast. It might not need to. You don't need a car, effectively. There's situations where you could just have the robot get there somehow without a car, right? So that's super interesting. I mean, it could be a car on its own, like it could have wheels or whatever, if it needs to.
Actually, the IIT, they're the makers of iCup, a small humanoid, one of the biggest European robotics initiatives. They have a team that's currently working on making them fly with rockets. Like anti-gravity that has sort of small, not rockets, jet engines.
Yeah.
So maybe, who knows, we might soon have flying robots.
That's cool. Another question I've got actually on this same topic is, so we're talking about telepresence here, right? And, Alona, earlier you showed how to move the head around, and, you can do it physically moving your head. But what if you want to walk around, maybe a big, I don't know, show floor, or maybe a big factory or whatever? I mean, you're not going to be able to walk around in your house replicating the show floor, right, or the floor or whatever. So how would you do that in a real scenario?
We have an infinite treadmill, so currently this is our approach to tackle this. And currently, since Roboy does not walk, which is a question people usually have, I'm surprised nobody have asked this. So this guy 3.0 cannot walk, and he has a wheelchair. So you basically drive the robot in the wheelchair, and with the wheelchair it's very simple. You have a thumbstick on your joystick, on your controller, and you navigate like that.
So I guess the approach you're taking is, rather than having it move as a human, you have it. Well, I guess you have it on a wheelchair. So, but you have it. You don't have it walking. I guess that just adds complexity, and it's probably not needed, right? To some extent.
I mean, of course, this is an intermediate goal. It's just pretty hard.
Yeah.
I mean, I think pretty hard is a slight understatement. I mean, it is excessively hard. So, and we are no way close to be funded well enough to actually be able to have our own walking group.
Yeah, and I think but it does raise the point of, you need to actually. We were talking about before about having it autonomously drive, move around, right? But what about, you could have a joystick rather than. I mean, you don't actually have to physically move around, right? So I think that's an interesting aspect from a user experience. Right? Would it be more suitable to have you walk on a treadmill, or actually is the best way to have you move a joystick? I mean, in one way you feel more part of the robot. In another way you feel more kind of distant, right? But at the same, from the kind of robot perspective, or from the people interacting with the robot perspective, the outcome is actually the same, right? So I'm interested if you've got any thoughts on what is the best approach overall, if there is one.
So I think there's a huge. So one of the main reasons. So like teleoperating robots is not a new thing, and one of the things that you'll see that you see is, if you're teleoperating robot and you're using a joystick also for the hand, so on, you get the performance versus the human, which is about 100 times worse. So you'll be 100 times slower, and that's just because it's super unintuitive for us to map. Now, for locomotion, I think it depends. So if you're if you have the robot and it's sort of wheeled, I think as long as it's wheeled, the joystick is probably a good approximation. But nonetheless, like if you're using your body, you're doing a lot of intuitive things, right? If you're thinking about, you're standing in front of if you're cooking, for example, you're standing there, and then you turn half your body, and then sort of the rest of your body starts to rotate with it, because you're grasping for something from the fridge. Now, if you actually had to rotate, press the controller and turn it a bit to do this, it would become quite unintuitive. But if you have a big factory floor and you want to get very fast from A to B, then it's probably a lot less comfortable to actually having to walk from A to B than to just sort of stand there and have a controller where you push forward and be like, okay, now, let's just wait until we're there. So I'm driving a lot myself around on on a sort of a segue. Also a bit, I mean, for me to explore this, what would I want? And this is actually quite an interesting thing, because if you're you can use your body also to do this balancing. I'm not sure how this would work though, if you, once it's a robot that's balancing, if you could still sort of use the intuition of the body to control it. Sounds like an interesting project.
Yeah, it's interesting. I think what's interesting to me is that, you know, there are some things that you want to replicate one-to-one, right? And there are some things that actually you can think of extending, you know, that can extend the human behavior or the human. So you mentioned about, you know, walking fast, right? And you know, you probably wouldn't be able to walk as fast as a robot could. So could you, you know, you need an extension of what you could normally do. Like instead of running on a treadmill, you'd need a button that could just say, you know, go forward fast, right? But then in other contexts, actually having that kind of direct feedback is super interesting. So yeah, I think it is an interesting topic, and I imagine it's probably, you know, there's probably multiple people, you know, as well as you guys looking at it. So, you know, how long will it take before we have a solution to this, you'd say?
So I think it is not something that has like a sort of one-step solution. It's more like we'll see gradual progress towards it. I mean, to the point where we have perfect telepresence, I think that's at least 15, 20 years down the road, because it's a lot of things that are just very purely tackled so far and purely understood. We haven't talked at all about haptics so far, but it's a very important sense for us, not just for the hands, but generally your body. Skin is actually one of the, if you think about our senses and what we're trying to do, we're trying to sort of trick every sense into perceiving something remotely with as little effort as possible, and sort of as close to the outer reality as possible. So tricking our ears is super simple. You put the headphones on it, and it's very hard to hear the difference. Like you have transparent, and you feel like it's if you're actually there. For the eyes, we're slowly getting there with VR headsets. For the nose, it's also it's super hard to do, but it's quite localized. So you actually just need this local area. But for your skin, it's a pain, because you actually have your whole body is covered in it. So you need to you need to trick it everywhere. So that's really tough. And then also skin is 4 senses in one, on top of each other. So you feel pressure, you feel touch, which is not the same thing. You feel temperature and you feel pain. And basically those senses are sort of like at the same place, and we don't have a good way of just sort of stimulating them independently of each other. And at this density that we need to do it. So this is like, it's a whole range of stuff that needs research on, and that's just skin. And then we also have the other thing on the robot, right? We need to actually have a skin on the robot to feel all these kind of things. So to answer your question, like, I think it'll take quite a bit of time, but having the first useful commercially viable telepresence system is not very far away. Like we're about to enter these markets. Not just we, but as humanity, we're about to enter these markets. There's the first other companies and startups that are coming up with viable telepresence robots.
Awesome. Well, I mean, I think we covered a lot, and I think there's probably, you know, as much to cover, definitely more actually to cover than what we have covered so far. But you know, this is a super interesting space, and you know, thank you so much, guys, for joining me and chatting openly about what you're building and the future of robotics and telepresence mostly. I think, you know, it's a nice way to end on the fact that I think, you know, you're saying we're about to enter a new era, right, of telepresence, and I think that's exciting. So thank you both. Do you have any last words or last thoughts or last, you know? Also, a shameless plug for both of you. So if you've got anything that you want to share at the end with the audience, I give you some space.
Alona, do you want to start there?
No.
Yeah. So I think maybe 2 small things. One, just to answer the Suela's questions, you'd need to have the feedback that pushes the pilot over. Maybe, Alona, you could turn the camera real quick and show the thing that we're actually building over there.
So this is gonna be difficult.
Yeah, so what you're seeing in the
Can
back,
you see this huge cage?
this huge cage is actually our approach of creating a force feedback display for the full body, so that when the robot is, for example, bumping into a wall, you actually feel this. So this thing can actually push the pilot over. So this is one thing, and you're becoming like a puppet in it. So this is really cool. It's a really cool tech we're currently working on, and we have a student team that working this. We're very closely collaborating with TU Munich and HU Zurich and other universities. So if you're a student and you want to do the real thing, have someone else pay for your mistakes, sort of, and learn from it. Come to Roboy, join Roboy as a student. I think this is by far the best thing and the most valuable thing you could do in your lifetime, of course. And apart from that, we're always looking for companies and challenges who want to work with us. So if you're there and like okay, they are crazy, let's do something together. Let's do it. Roboy is pretty good in drawing crowds. So like whatever we build up together, you can be sure it will be seen. And thank you so much for having us. It was a huge pleasure. Great talking about our vision, of course. I mean, I could keep on talking this for days.
Awesome. So. I think it's it's super interesting, and I see actually Roboy reacting as well.
Yeah, he's a bit intelligent.
So Alona, up to you then. Any last thoughts?
Yeah, so if anybody has awesome, great tech ideas, please reach out to us on social media. We're always up for experimenting, and yeah, so that would be my message.
What is your social media like? Your favorite? What's the channel for people to contact you on social media?
So it's on Instagram, it's Roboy Junior. On Facebook, it's Roboy Project, and on LinkedIn, it's just Roboy.
Cool. And so we'll share that later with everyone underneath the description. And also, you guys, I wanted to share the GitHub that you have for all the open source stuff that you're building. So thank you so much for advancing humanity for us. So. You got a big task here, so thank you so much for sharing with us your work. It's super exciting. Thank you again, and have a great evening, everyone. Thank you all for joining in today.
Thank you for listening as well, and thank you for having us. Have a nice evening. Bye-bye.
Bye-bye.
Bye.